In section 5.3, we're going to talk about trigonometric functions on something called the unit circle. The nice thing about the unit circle is we're going to spend quite a bit of time talking about this. So by the time we get to the end of trigonometry, you should have the unit circle basically memorized. The unit circle is a circle drawn on the coordinate plane. But what's special about the unit circle is that its radius is 1. So remember, all radii have a circular congruence, so it doesn't matter if I go from the origin to this point over here or from the origin to this point over here. Both of those units are length 1. We're going to talk about those special angles on the unit circle, the ones from the last section. Remember your 30, 60, 40, or 30, 60, 90 and your 45, 45, 90 triangles? We're going to specifically look at angles on the unit circle that their distance from the x-axis to the terminal ray is either 30, 60, or 45. So, because this is unit 1 length, if I make myself a nice little right triangle here, then this distance here, we're going to call it x. I don't know how many units long it is, but I know it's on the x-axis. And then this unit here, which is parallel to the y-axis, we're going to call it y. So theta will be this angle here. So this point up here would be at the ordered pair x comma y. Well, the sine of theta, because sine is opposite over hypotenuse, would be y over 1, which is just y. Oh, wait a second, sine is just y. And then if we find the cosine of theta, which is adjacent over hypotenuse, it's x over 1, which is just x. So it turns out that the ordered pair where a terminal ray hits the unit circle is going to be the ordered pair cosine theta, comma sine theta. And the reason is because the cosine of theta is equal to x, and the sine of theta is equal to y. Because there's only one point where any angle on the unit circle is going to hit the unit circle, we sometimes call sine and cosine the circular functions. So we said that this is a radius 1. That means that this ordered pair at 0 degrees must be at the ordered pair 1, comma 0. Because it's on the x-axis, so the y-coordinate has to be 0, and it's only 1 unit long, so the x-coordinate must be 1. At 90 degrees, that must be the ordered pair 0, comma 1. At 180 degrees, this is the ordered pair negative 1, 0. At 270 degrees, this is the ordered pair 0, negative 1. And then we're back at 360 degrees, whose angle hits the unit circle at 1, comma 0. The domain for both sine and cosine is going to be all real numbers. And the reason it's all real numbers is because you can plug in any angle measurement, positive, negative, decimals, and you'll always get an output. But the range for our circular functions sine and cosine are going to be between 0 and negative 1. Nope, not 0 and negative 1, negative 1 and positive 1. And we'll talk about that a little bit more on another day when we start to do graphs of sine and cosine curves. We've already talked about the sine of theta is y over 1 and the cosine of theta is x over 1. Our other trig functions on the unit circle, tangent, which is opposite over adjacent, is going to be y over x. And then I'm going to do my reciprocal functions. The reciprocal of sine is cosecant, so it's 1 over y. The reciprocal of cosine is secant, that's 1 over x. And the reciprocal of tangent is cotangent, which is going to be x over y. But remember, do you have to know these definitions? Not really, because they're just the same as using opposite, adjacent, and hypotenuse. In example 1, we're going to use the unit circle to find each value. So I drew myself a picture because this is going to help us out. We want to find the sine of negative 90 degrees. Now remember, if you start here in initial position, then negative 90 degrees, you have to go this direction, so it must be down here. Now, if you can remember what ordered pair is down there, and you can remember if you come over here, sine is y over 1. Well, in these ordered pairs, remember the first coordinate is the cosine of that angle, and the second coordinate is the sine of that angle. So if I want to know what the sine of negative 90 degrees is, it must be negative 1. If I had asked you for the cosine of negative 90 degrees, you would have told me it was 0. Now let's go do cotangent of 270. Well, 270 means we're going to go this way. Well, guess where it is? It's in the same place as negative 90. But cotangent was x over y. So let's use x over y. X is 0. Y is negative 1. And 0 over negative 1 is 0. So the cotangent of 270 degrees must be 0. Example 2. The displacement in centimeters of an oscillating spring from its point of equilibrium is d equals 12 times the cosine of 180 degrees t, where t is the time in seconds. The spring is farthest from equilibrium at t equals 0 and t equals 1 seconds. What is the spring's largest displacement? First of all, displacement means distance. Oscillating means that the spring is going up and down. So if you have a spring and you pull on it, it's going to kind of go up and down and up and down, and friction will kick in, so it'll eventually stop. But that's what it's talking about. Equilibrium means where the spring is when it's not oscillating. So if the spring stops oscillating, whatever position it's in is what its equilibrium point is. So let's say that we're going to pull on that spring and we're going to make it oscillate. I'm telling you that the spring will be its furthest away from its equilibrium distance at t equals 0 and t equals 1. So we're going to do two problems basically. We're going to plug in 0 for t, and then we're going to do this again by plugging in 1 for t. So what's 180 times 0? It's 0. So we want to know what's the cosine of 0. We're going to multiply that by 12. And then here, 180 times 1 is 180. So we're going to find the cosine of 180 and multiply that by 12. Let's go to our unit circle. Here's the initial position. 180 is over here. It's at the point -1, 0, where cosine is the first coordinate and sine is the second. And then 0 is over here, and the ordered pair over here is at 1, 0, where this is cosine. So the cosine of 0 is 1, and 12 times 1 is 12 centimeters. The cosine of 180 is -1. Oops, let me get rid of that. So we're going to multiply this by -1, and we get -12 centimeters. Now, can you have -12 centimeters? It just means that it's 12 centimeters the opposite direction. So it can go as far as 12 centimeters this way, or 12 centimeters this way from its equilibrium position. Now that we've focused on angles that were on an axis, now we need to talk about angles whose terminal ray is within a quadrant. We're going to focus on those special angles, the ones that were 30, 60, or 45. So let's look at 135 degrees, which would lie in quadrant 2. Remember we said the ordered pair where it hits the unit circle is going to be cosine comma sine. Problem is I don't know what ordered pair this is right now. Well, this is how we're going to figure it out. What we're going to do is we're going to create a right triangle with the x-axis. So we're going to drop a perpendicular to the x-axis. And there's my right triangle. This is theta. Theta will always be a reference angle. Remember, a reference angle is an acute angle between the terminal ray and the x-axis. So if that's 135 degrees and this is 180 degrees, then theta must be 45 degrees. 45 degrees, we know what the sides of a 45 degree angle are, or triangle are. It's x, x, x the square root of 2. But there's another thing we have to worry about. And we have to worry about the fact that we're in quadrant 2. Because the coordinates of the ordered pairs, the x coordinates will be negative in quadrant 2. You can worry about that at the end of the problem. So for right now, if I want to know what the 6 trigonometric functions are for 135 degrees, if I find the reference angle, now I can do sine, cosine, tangent, and the reciprocal functions will be the reciprocals of those 3 answers. And if you hear weird stuff going on in the background of this video, I apologize, but my cat is going crazy because there's a box. The sine of 135 degrees, opposite over hypotenuse. The cosine, adjacent over hypotenuse. And the tangent, there we go. It's going to be opposite over adjacent. So this is going to be 1 over the square root of 2, which is square root of 2 over 2. This is also 1 over the square root of 2, which is square root of 2 over 2. And then this is going to be 1. But in quadrant 2, the x coordinates are always negative. And remember, the ordered pair is at cosine comma sine. So what's negative? Cosine. So we're going to make that negative. Now reciprocals, when you have a negative, the reciprocal of a negative number remains negative. So now let's go flip them. The reciprocal of sine is cosecant. So the cosecant must be square root of 2 over 1. Remember, I use this one so that I don't have to rationalize the denominator again. The reciprocal of cosine is secant. That's going to be negative square root of 2, because if this is negative, then its reciprocal is negative. And cotangent, the reciprocal of 1 is 1. And those would be your 6 trigonometric functions. So let's go back and look at the unit circle here. Quadrant 1, 2, 3, and 4. In quadrant 1, both coordinates are positive. That means that cosine and sine are both positive. In quadrant 2, x is negative, but y is positive. So cosine is negative, but sine is positive. In quadrant 3, everything's negative. So both cosine and sine are negative. And in quadrant 4, x is positive, but y is negative. So cosine is positive, but sine is negative. Well, we have another way of trying to remember which quadrants our trig functions are positive or negative in. ASTC. So starting with quadrant 1 and going to 4, it's all students take calculus. Maybe you don't like that. Sometimes students like to use all students take cake, but this is math class, so we're going to say all students take calculus. What each of those letters represents is which trig functions are positive. So all of the trig functions are positive in quadrant 1 because both coordinates are positive. But in quadrant 2, only sine and its reciprocal are positive. Everything else is negative. So we found out in that last problem, cosine was negative, and so is secant. In quadrant 3, only tangent and its reciprocal are positive. Everything else is negative. If you look up here, one of our definitions earlier for tangent was y over x. Well, what's negative divided by negative? It's a positive. That's why tangent is positive. But cosine and sine are both negative. And in quadrant 4, only cosine and its reciprocal are positive, and everything else is negative. And it's all students take calculus. It starts in quadrant 1 and it goes around to quadrant 4. The last problem that I'm going to do in this video, and I'll make a part 2, is this problem. Example 3, use the unit circle to find the 6 trigonometric functions for 210 degrees. So let's do a couple things. First of all, let's figure out where 210 degrees would be located. So this is 0, 90, 180, 270, and then I'm back at 360. So 210 must be in quadrant 3. All right, so if 210 degrees is in quadrant 3, in order to find the 6 trigonometric values, we need to know the reference angle. How many degrees is it between 210 and the x-axis? Well, if the x-axis is at 180, the difference is 30 degrees. All right, so now I have this 30, 60, 90 triangle. So if I have a 30, 60, 90 triangle, so now let's get rid of this. And I call that 30. So if that's 30 degrees, this is x the square root of 3, and 2x. Now what I'd like to do is I'd like to get to the point where for the 30, 60, 90 triangle, we instead call it 1 square root of 3, 2, and just get rid of the x's because they're all going to cancel anyway. And then for the 45, 45, 90 triangle, we'll just call it 1 square root of 2. Okay, so now we're going to call it 1 square root of 3, 2. So I'm going to, maybe I'll make a better picture. All right. There's my unit circle. There's 210. This is 30 and 60. So this is going to be 1 square root of 3, 2. But I want you to notice what quadrant we're in. We're in the quadrant where only tangent and its reciprocal are positive. That means everything else is going to be negative. So at the very end of the problem, we will worry about what is positive and what is negative. So the sine of 210 degrees, opposite over hypotenuse. The cosine of 210 degrees, adjacent over hypotenuse. The tangent of 210 degrees, opposite over adjacent. That's going to become square root of 3 over 3. Now, only tangent's positive, that means these two are negative. So now when I go do the reciprocal functions, the cosecant is going to be negative 2 over 1. The secant is going to be negative 2 over the square root of 3, which is going to become negative 2 square root of 3 over 3. And the cotangent, I'm going to flip this one, so it's going to be square root of 3 over 1. So what I did was I started the problem by determining what my reference angle was. That told me which of these two special triangles to use in order to find my 6 trigonometric functions. I didn't worry at the very beginning that it was in quadrant 3 and that only tangent was positive. I first started by finding the ratios. Then after I found the ratios, I went back and said, oh, tangent's positive, so the other two are negative. If a negative number has a reciprocal, its reciprocal will also be negative. And we're going to call this part 1 of trigonometric functions on the unit circle, and I will put part 2 in a separate video.